Hey everyone, I bet you're sick of this picture. The reason I want to concentrate on this picture again is because I think everybody on the forum is a lot further ahead now than what we were even 6 months ago. I think the way some people are thinking about this is still too complicated. I think there's a lot of people out there that are looking for mystery, voodoo magic, things that just really don't exist. If anyone were to take the time and read through my HiIQ website and go to the reference section and read through and just look at one thing in particular, is what the knowledge or what the level of knowledge was for each of those people that have succeeded before us, what their level of knowledge was in electrical engineering and specifically electromagnetic induction. What people are not realizing is the load itself requires a voltage and a current, which we've been through plenty of times in the past. I've got videos and videos about it. But what people are possibly not realizing is that this was their goal. Their goal specifically was to make the electron move in the wire down the wire to power the load. Now, there's a whole bunch of people that are researching things that have got absolutely nothing to do with the electron, absolutely nothing to do with trying to make the electron move. And to be honest, I see so much of it that I just see people wasting their time, and I wish I could somehow magically flick a switch and put them on the right path. If people want energy, then people need to focus specifically on electromagnetic induction. It really is that simple. Electromagnetic induction is incomplete. Electromagnetic induction has got holes right throughout electromagnetic induction. I think any average physicist would probably tell you that yes, there's issues in electromagnetic induction that still to this day still have not been resolved or adequately explained. A lot of people will argue till the cows come home on that, but the simple fact is that current is nowhere in electromagnetic induction. Yet even some physicists use the term current when theorizing about electromagnetic induction. And the truth of the matter is, it's got nothing to do with current. It's got everything to do with EMF, which is measured in quantity of volts. Okay, EMF is voltage, and that's all. That's all. It's nothing to do with current. If you want any prediction or anything on current, you have to move to Ohm's law, and that's basically all that you can use for current. Now, it's not sufficient. It doesn't explain the direction of the current. It's assumed that the current, well, in the old days it used to be from positive to negative, but now we know that the current moves from negative to positive. Okay, there's different sets of rules depending on what theory you follow. I try to keep it simple for everybody. I use the old theory, most people know that already, where the current moves from positive to negative, but that's not actually true. It's different. But to change that, then you've got to change everything. Instead of using things like the right hand grip rule, you then have to use the left hand grip rule. So it's not just a simple case of just changing the direction of current. Okay, so today's video I want to specifically focus on the change of magnetic fields and how these coils are actually working, because I think a lot of people just simply still don't understand it as such. Many people seem to be trying. Most of our forum members are mostly successful in their replications. Some of them are a little bit further ahead than others. This unfortunately is just how it works. There's not really much more I can do on that. I wish I could do more to help. What people have to realize is I don't have all the answers. I know a great deal of what's going on, perhaps more than most other people out there, but I still don't know everything. I'm still learning, so I want to make it very clear. Again, I've said this right from day one, that I'm still learning. There's some things I don't know. I can't predict these machines. I can't just say, right, do X, Y, Z and it'll work, because that's not the level that I'm at yet. I'm still learning. In saying that, it's fairly easy for me now to make one of these machines work. I have a pretty good grasp on what's required to make this work. Okay, on my HiIQ website, if I scroll up, I'll show you the home page. So hiiq.org, the House of Energy. We go through many different things. We've got lots and lots of resources here. Let's just change the page. Okay, now you can see a little bit better. There's several resources here that I'd like to point people to. First one is a reference. In the reference section, I go through and reference what I believe to be the most important people in history. The Don Smiths, the Floyd Sweets, all of those sort of people, Daniel McFarlane Cook, Clemente Figura, all of those people, by far, Andrei Malenchenko, Terrell Capanazzi, all those sort of guys. I have as much information as I had at the time uploaded to these links, so you can just click on the link and it'll take you to documents, images, videos, all of that sort of thing. So you can go, you can have a bit of a look, you can do some research, you can look and see what they're actually doing, what they're showing you, all that sort of thing, all that good stuff. Now I just recently had a conversation with one of the forum members about Clemente Figura. I don't know if many people know this, but this is well over 100 years old. It was about 1903. He actually got one of his first patents, I believe, I think, if I'm right. 1902 there you go, even earlier. So this guy was working on what we are working on well over 100 years ago. Okay, it's not quite, but about 118 years ago, not quite 120. Which is pretty disgusting when you think about it. These are the sorts of things that, you know, as a species, we really should be ashamed of ourselves. This is very poor form for a species to actually go backwards. Over 100 years ago, this guy had the answers that many of us currently seek, which is pretty bad. Anyway, I want to point specifically to our support section. Again, on the website hiiq.org, electrical energy. Okay, what people don't realize is the average generator all works around standard, typical, everyday electromagnetic theory. A coulomb's a coulomb. Okay, the current is basically 1 coulomb per second equals 1 ampere. So it's not rocket science. It's all made up from the electron and the electron moving. Okay, every single one of the people that I've just shown you has said the same basic thing. Okay, Stephen Mark basically said it's just the knowledge of the coils, and it is just the knowledge of the coils. It really is. Clemente Figura told specifically what he was doing. This was 100% no confusion, no nonsense, no silliness. He said very specifically, in studying the dynamo, the induced, basically he was looking for voltage, he was looking for current. Okay, he was specifically moving toward it's very hard to say a solid state version because this part G wasn't actually solid state, but He was looking at a solid state, in those days a dynamo, which is the same as an electrical generator these days. A dynamo quite often was DC instead of AC. It's really the only real difference. Other than that, the generator and the dynamo are pretty much the same things. And he was looking at the way that the magnetic centers basically changed in magnitude. Okay, so what he's doing here is he's not actually moving the magnet past the coil, which is what we think about in electromagnetic induction. He was looking at what the coil was doing when it would see the magnet. Okay, and somewhere here he says, I'm just looking for it, reduced and increased intensity. So what he's doing is he has built a machine, according to his own words, that the magnetic field increases and reduces in intensity to make his machine work. Okay, now there's no rocket science in that. Today we know that the magnetic A vector potential is what makes a transformer work. Anyone that has studied the greats before us will see that most energy machines are based around, not specifically on, but around the same model as the transformer. The transformer is basically the start of all of these machines. Okay, they all have coils, they all have changing magnetic fields. If you go through, you can see the same basic model throughout. Okay, there's only several ways that you can generate energy. If you're looking for energy, you need voltage, you need current. There's only several ways that you can generate voltage. There's the change of magnetic field, or you get some cat fur out and you rub it. Okay, it's not rocket science. Now, difference between static and dynamic, obviously that's two different sciences. Many people go and try to argue the differences, but really at the end of the day, a magnetic field changing in time is doing the same thing as rubbing cat fur on the coil. It's shifting electrons from one point to another via a change in electrical potential. Anyway, I want to point this out because this is really, really important for moving forward. What we're missing, or what some people are missing, is as simple as anything else, is the idea of voltage and current. Now, this image is an image I've had up for a long time. I put this little bit here in the middle to make it look like this coil was supposed to be connected directly to this coil over here, not only electrically but magnetically, to give the electrical and the magnetic perception that these two gold coils were linked. Okay, and that's why I called them partnered output coils, because they are exactly that. They are partnered output coils. The green coil is the input coil. Okay, partnered output coil 1, partnered output coil 2. You can see we've got red arrows indicating the magnetic field. Magnetic field must oppose. Now, most people that have replicated this, most of them tell me, oh, I've got nothing but a 50% efficiency. And then I say, oh, well, if you apply the right hand grip rule, what do you get? Do you get magnetic fields opposed? And no, I don't. Well, you've got it wrong. It's just a basic transformer. Now, if you build a basic transformer, you're going to get anywhere from about 50% to about, some really good transformers are about 95%. But you're never going to get over 100% with a transformer. A basic transformer, as it stands, is under unity. It's under unity because simply it's a symmetrical device. Okay, you have one input coil, it opposes the output coil. There's a symmetrical and energy transfer or transformation from the primary coil to the secondary coil, and in any transformation there's always losses. There's always losses. So from the primary coil to the secondary coil, If you can't make up your losses, it's always below unity, and it's always below unity because it's symmetrical. Always. Transformers, every single one ever built, except for some of the people I've just mentioned before, all of them are symmetrical, all of them are under unity. You can't build an over unity transformer unless you build an asymmetrical one. It's got to be asymmetrical. To do that, you've got to have an input coil, you've got to have output coil 1 and output coil 2. Each coil, each secondary coil, the gold coils, need to be thought about as a battery, okay, each having a voltage, and then once you have a voltage, thus the current will then flow. Now, any coil that's exposed to a changing magnetic field, it doesn't matter what configuration you have, any coil that's exposed to a magnetic field, if it's in such a fashion that the voltage is generated, a current will flow. Okay, this is standard electromagnetic induction. There's two forms: flux cutting, flux linking. Now the forms have been changed some time back, but it's not really been properly adopted into the magnetic A vector potential and phi, which is the flux. Okay, so I'll show you that now. Okay, here we go. Richard Feynman was the person that made this, or I should say Sir Richard Feynman, one of the most famous scientists or physicists of all time, made the A vector potential popular. You can see J indicating the current here, okay, the current in a solenoid. A is the electric field, which has curl being goes around in a circle and closes on itself. Phi, which is B, which is the magnetic flux. Okay, now the magnetic flux is completely contained inside the core. There's no magnetic flux out here. That's the indication of the arrows in here, and no flux arrows outside the core, except for the top and bottom, obviously. Okay, so when magnetic field is contained inside the core, the magnetic A vector potential is left behind on the core, but only when B is changing. Okay, phi or B must change in time to make the magnetic A vector potential also change, and thus if we have a coil wrapped around here, the change in the magnetic A vector potential will induce a voltage and therefore allow a current to flow within the coil. Remembering the coil is insulated, so effectively no charge can be transferred from the magnetic field B or phi. The electric field here, essentially being that it's insulated, might be able to influence the particles within the coil, but essentially there should be no charge that's passed from A because of the insulating factor and the coil. Okay, so that's the magnetic A vector potential. If we were to imagine a single flux line, we wouldn't need a core. Okay, a single magnetic flux line would have the same A vector potential around that particular single flux line, and obviously if we can get all the flux lines together and multiply the flux lines inside a core, then that multiplies the A vector potential as well. Alright, so this has been around since early 60s. I think it was about 64, 65 or something like that the 3 volumes of physics came out. Please forgive me if I'm wrong, but it's roughly about that. So it's been around for a long time. Most transformer technicians work with B and A now. Most people in the field have completely forgotten about all the other equations that don't really apply anymore. VXB was replaced by phi, B and A. I just want to point out real quick, this is a post that I posted on the same thread, connecting the dots to energy, the A vector potential, the A field I think it was. Floyd Sweet referenced his VTA as the oscillator or vector oscillator. You could actually say A vector oscillator here, and that's why I've written A vector oscillator up here. He referenced that particular oscillator phrase being the VTA several times in different places. So I think it's really important at this stage to make that connection that the magnetic fields B and the electric field A oscillate under certain conditions, and this is also something else that I want to play a short video about. Tom Bearden refers to the same oscillations, and only under the oscillation condition can energy be extracted from the vacuum.
Anything that's stressed, you can tap energy out from God Almighty forever, if you can get it to do this process and get over gain 1, which you can do under the oscillation condition. Now, I ain't going to tell you how to do that. That's the inventors that I work with, their secret. But that's the principle, and it works on the bench. You can tap stress itself.
Okay, I just want to be very careful how I state these words, because a lot of people are just going to sort of switch off and, oh, you can't get extra energy. We're not getting extra energy. We're getting energy from exactly the same place as the electrical generator does. Okay, the electrical generator been around for a long time. Okay, we've just talked about it. This is one of the big GE electrical generators. Where does the energy come from? The energy does not come from the shaft. Okay, some physicists will say the energy comes from the shaft. Well, look, I'm sorry. If you can find some sort of an electrical connection via an insulated coil that's on a completely different part of the apparatus, not the rotor, but actually in fact the stator, if you can find some sort of electrical connection and convert that shaft torque in the form of mechanical energy as torque into electrical energy to output on the coils, then you'll convince me. But there's no way, there's not an argument in the world that will support any nonsense like that. Electrical energy from the generator comes from the same place as what our machines do. Okay, they're exactly the same machines, it's just a different inception of the same device. Okay, coils, moving magnetic fields, has to have motion. Okay, it has to have change of the magnetic fields. So it's exactly the same place. There's no difference from these great big whopping expensive monstrous machines and the Terry Carpanazzi device or the Floyd Sweet device or the Lester Hendershot machine, or they're all the same. They're all exactly the same. And look, honestly, if you sit down, if you do the research, you will see it. Okay, they tell you. Floyd Sweet tells you plenty of times where current comes from and what's required to actually make the current flow. It's the documentation, the research, the facts, the evidence. It's all there if you sit down and do the research. Okay, these machines are an absolute waste of time, waste of money, and waste of space. Okay, they're noisy and not necessary. You don't need them. All you need is a few coils sitting there, and like Clemente Figueroa said, a changing magnetic field. Okay, the basic laws still apply. Okay, to calculate the voltage, Floyd Sweet tells us in his documents. He basically says in several different places that the same rules of Faraday's law of electromagnetic induction still apply for voltage. Okay, if you want 120 volts, then you've got to figure out a coil that basically has the cross-sectional area, the turns, the changing magnetic field in density, B field, and then you've got to obviously make it work. So where Floyd Sweet said it was a vector oscillator, that's exactly what it is. It's exactly a vector oscillator. It's the time rate of change of the A vector potential. Okay, so vector oscillator, he's saying vector oscillator, but if we said A vector potential oscillator or A vector oscillator, it's the same thing, same basic thing. Okay, and here again, therefore it matters little to these induced currents if they were obtained by the turning of the induced. Okay, so basically the turning of the induced is the rotation of the rotor, or by the variation of the magnetic flux that runs through them. Where else have we seen that before? We've seen a very similar quote before, haven't we? Floyd Sweet says something almost exactly the same. Okay, the source of energy is unlimited, and it is unlimited. It's everywhere. The virtual vacuum of space itself, structured by a motional electromagnetic field, is the powerhouse. A term, time-varying flux modulation. It's almost exactly the same thing as what Clementi Figura said. Almost exactly the same thing. Does not imply any separations of the lines of flux. We don't need to separate the lines of flux. There's no need for the big electrical generators. All we need is a time-varying flux modulation, basically. It's the same basic thing. It's the same basic thing throughout. If you go back, if you read the Cooke patent, I think that was something like about 1857, perhaps, something like that, but it was a long time ago. The Cooke patent talks about the same sort of thing, changing magnetic fields. Okay, he talks about modulating, or the strength of the magnetic field changing in time. It's the same basic thing. Okay, when Michael Faraday discovered this in 1831, and then after that it was Oersted, I believe, in 1832, independently. They didn't realize what they'd discovered. They'd discovered a whole new world, and now 189 or whatever it is years later, we're still investigating the most simple basic things out there. Now this video is worth watching because Floyd Sweet, he only flicks on this little oscillator here, which is only capable, I think, of 45 watts maximum. I think, from memory, I think it says there if you go and watch the video. He flicks the oscillator on, and the VTA here bursts into life straight away. You can hear the fan running in the background, the whole lot, and there's no way that turning on a tiny little oscillator like that would make anything in this machine other than a very small magnetic field changing in time, which is a regulator. Okay, the input signal is a regulator. It's the time change that your partnered output coils require to do their own electromagnetic induction without having any extra source of energy input. Okay, it's not rocket science. These coils here, this coil here, and this coil here, if there's a changing magnetic field in time from this coil that points that way, and in this coil here, if there's a changing magnetic field in time that points that way, then this coil is going to be the primary for this coil, and then this coil is going to be the primary for this coil over here. The green coil regulates the time rate of change. Okay, the time rate of change is part of the equation in electromagnetic induction, d phi dt. N is the turns here, and the negative sign is Lenz's law, which we see the negative sign. The big red arrows indicate the negative sign. So Lenz's law here is between this coil and this coil here, the gold coils. So each gold coil has Lenz's law, because obviously equal and opposite. So we have symmetry in this machine, but at the same time we have asymmetry as well. Asymmetry is the input coil up here, makes this machine asymmetrical. Another way to think about it is you could think about this coil over here being a primary, this coil over here being a secondary. Okay, primary coil, changing magnetic field and time, generates a voltage. Voltage is loaded. Okay, it's very important you have a load on these machines, otherwise they don't work. Got to have a load. Changing current, okay, is the same as the changing magnetic field. Same thing. Okay, so magnetic field is equal and opposite on this coil over here. Okay, this gold coil here could be a secondary, primary over here. So the primary voltage that's applied to this coil, and therefore the current, generates a voltage in this coil. Voltage in this coil then will allow for current to flow. Now there's nothing here the same as in the big GE generator that we just saw. There's nothing here that inputs energy into the coils. Okay, it's electrons. The copper atoms themselves have the electrons around the atoms. Free electrons will then flow if they're put under a pressure. Pressure is a magnetic field changing in time, and obviously the voltage on the terminals, which creates an electrical pressure, if you like, will then allow for the current to flow. If you strip away all the electrons from the copper atom, Floyd Sweet actually goes through and does say in one of his papers that it won't change the structure of the metal, the copper, that it'll still stay the same because the structure is such that, he does go on to say anyway, but the structure is such that it won't change the metal's composition. I think obviously over time, I think it probably would make some changes to the copper. Over time you'd probably have to replace the copper coils, which is not a big deal. You know, I mean, if you're supplying, you know, excuse me, some of these big generators are, you know, 50, 100, and even 200 megawatts. So if you're supplying a couple hundred megawatts and it costs you a few copper coils, at the end of the day, it's probably not too much of a drama. So anyway, again, this coil is about simplicity. Okay, simplicity, changing magnetic field. Look, it's called parasitic inductance if you're dealing with microelectronics or electronics in general. Any changing magnetic field in time creates a voltage, obviously on copper traces that are on the PCB or inside a chip, and they quite often want to get rid of that. And realistically, the only way to get rid of that is either have the coils far away from changing magnetic fields, or keep the coils, or keep the traces at least very, very short to reduce the noise in the circuit. Okay, we want to capitalize on that. Okay, we want big coils. We want a few, you know, quite a few turns. We might want 50, 100, 200 turns. Now this is really important, really important. It took me a long time to figure this out. You don't want too many turns. Too many turns is bad. Too many turns is bad because the impedance of the coil goes up too high. Now when the impedance of the coil is up too high, you just get high voltages, and realistically you get very little current. Okay, so you need to be very wary, very careful of the impedance of the coil. You don't want high impedance coils. You want low impedance coils. You're better off to make your coils a little bit bigger and have less turns of a thicker gauge wire than what you are to have very small coils with, say, 1,000 turns on them. So that's a very important fact, possibly where some people have gone wrong. And again, this comes back to looking at those before us. If you look at Ruslan, look at Akula, look at Teriel Kapanazi, look at what we know of Don Smith, look at what we know of Floyd Sweet. None of them, not a single one of them showed us a coil with thousands of turns of very small gauge on it. Okay, all of them. Let me pull up an example. Okay, here's an example that everybody knows about. Okay, what's he got? He's got 17 turns here, he's got 17 turns up there. Wire size possibly might be maybe 1.6 millimeters, something like that. Okay, tiny small coils with lots and lots of turns of microfine wire are not going to be beneficial, and it's just wasting your time, it's wasting your money, it's wasting your resources. So I urge you, please, if you're going to do this, please do it right. Please don't waste your time with tiny coils with hundreds of turns on them, because you really are just wasting your time. You need to keep your coils impedance down to a minimum. the time rate of change of the magnetic flux, which is controlled by your input coil, is what gets your partnered output coils moving. Okay, Don Smith, to be honest, I'll be straight up with you, I had read a little bit about Don Smith in the early days. I didn't really pay much attention. To be perfectly honest, I concentrated mostly on Floyd Sweet. It was maybe 5 years ago now. 3.5, let's say 3.5 to 4 years ago now, that I actually sat down and actually read some of Don Smith's stuff, and I thought, wow, this guy absolutely 100% is spot on. This Don Smith gave you everything correct. Okay, he might not have been the best speaker, he might not have been very clear at times, but what he did say, if you read between the lines and pay attention to what he's actually telling you, is 100% spot on. Okay, this Don Smith gave you everything. Everything here is 100% spot on right. If you look at my work, partnered output coil 1 over here, partnered output coil 2 over here, the silver coils, the red coil going in, I think he only has 4 turns up here on this one, whereas I have a few more turns than him, but basically the idea is exactly the same. There's no difference. Now if you use the right hand grip rule on this machine and use this point here as the negative, okay, you actually figure out the very same magnetic field as I've shown you here. Okay, big red arrows point in, or in Don Smith's case they point out. Okay, so there really is no difference. I mean, they still oppose, but whether the magnetic fields point in or point out, it's either South Pole opposing in the middle or North Pole opposing in the middle. It's the same thing really at the end of the day. It's still an opposition of magnetic fields. So these coils are super important. Okay, the cross-sectional area, CSA, I think we worked it out on the website. I think if you go up by a factor of 10, you get a voltage factor of 1,000, I'm pretty sure. We've got calculators on the website anyway, so if you go and have a little bit of a fiddle, work out a coil with a cross-sectional area known as CSA for short, abbreviation. So CSA, cross-sectional area, and just multiply that by 10 and look at what the voltage difference is. Okay, Floyd Sweet, you'll remember. Floyd Sweet, you'll remember some of the old ones, but you can see here this is one coil. Now it's a bit hard to see under here, but I'm pretty sure that's one over there, or one coil over there, or one coil here. So Floyd Sweet had 2 power coils. Each power coil had what he called bifilar coils. So there was two wires in each power coil, one coil being here, one being under his hand over there. Now I want to point out, look how wide this is. Okay, if Floyd Sweet was to put his hand up here, we'd be looking at least 100 millimeters, if not even more. Okay, so the cross-sectional area of Floyd Sweet's coils were huge, and over time he actually went up in size. Let me get another picture. Okay, I'm sorry, I wish I had a better picture on this. It seems to me that when everyone died, none of that information was put out into the public domain, which is pretty sad. This is one picture I managed to get from Walt Rosenthal's collection. Now you can see how big that top magnet is. Now anyone believes that magnet conditioning is key to these machines is just fooling themselves. So whatever you do, don't listen to the magnet conditioning idea. It's been proven wrong time and time again. Look, honestly, if you want any logic on this, has anyone else ever required magnet conditioning to make the machine work? Did Terrell Capanazzi condition his magnets? No, he doesn't even have any magnets. Magnet conditioning is a fraud, a lie, a hoax. It's not true. Okay, so concentrate on the coils. Concentrate on what the coils are doing, concentrate on the size of the coils, concentrate on everything to do with electromagnetic induction. Okay, I think, you know, if we pay enough attention, I think in the next probably few months or so, if all of us band together and do this, I think it's quite possible, quite logical, that we could all have a Floyd Suite style running vacuum triode amplifier. Now if you look up the definition of a triode, you will also see this happening. Okay, triode is something that squeezes off and then releases the flow of electrons. Okay, what else squeezes off and allows the flow of electrons? Changing magnetic field and time. Okay, it's what gets the moving electrons in the wire, isn't it? Yeah. It's so easy. I sometimes my patience runs a little bit thin, and I've got to apologize to everybody. It's so easy when you get to a certain stage, and other people boo-hoo you, if you like, is probably a term. Look, honestly, powering a load requires voltage, requires a current. The voltage and the current come directly from the coil. You have to terminate the ends of the coils. You have to bare the ends of the coils. Okay, so you can actually conduct the electricity. 1 watt over 1 second is 1 joule. So energy comes from the coil. Energy comes from within the coil. I just looking at this and trying to explain this and doing it for as long as I have, sometimes, like I say, sometimes it does get frustrating. I do try to keep my cool all the time though, so I do apologize. Okay, here's another photo. You can see the square box down here, the clear acrylic box. You can see that's the box that was used in the video that Toby Groats shared with us all. Okay, so that should be pretty familiar to everybody if you've seen that video. Okay, so just to reiterate, Don Smith is exactly right. If you follow Don Smith and his work for long enough, you'll eventually come to the same conclusion as myself. You'll eventually come to the same conclusion as Terrell Capanazzi, Floyd Sweet, and everybody else as well. Okay, so again, I just want to reiterate, look at the impedance of your coils. Impedance is the DC resistance plus the reactive, capacitive and inductive components. Okay, there's a resonant frequency of the coils. Before the resonant frequency, capacitive reactance is predominant. After the resonant frequency, the inductive reactance is dominant. So at resonance in the coils, and this is something I've tried to point out before in other videos, at resonance the coils only exhibit the DC resistance of the coils. There's no AC resistance of the coils. So effectively, if you were to have these coils here, if you were to have them changing at say 50 megahertz, there might be 600 ohms of impedance in these coils, even though the DC resistance might only be 0.3 of an ohm. So you have to realize that the frequency of the coils does affect the impedance of the coils, and that's why you don't want lots and lots and lots and lots and lots of turns. Okay, you want a reasonable amount of turns, but you don't want too many. Your turns has to match your core size for the voltage output. Okay, like in a common mode choke, voltage is restricted by the changing magnetic field. Okay, that's how it works. So if you restrict how the magnetic field changes, then a high voltage can't go through a common mode choke because the magnetic field effectively stops it in its tracks. That's how a common mode choke works. So we need to use that knowledge to actually do the opposite here and get the voltage up. Okay, 44 minutes. I think this video is long enough. I'm going to to post this. Now I've had so many negative comments, so I do apologise about this this video. The last few months, to be honest, has been pretty full on. Personal attacks, messages being left that are just really just negative. So I've got to apologise, everybody. Not in the best frame of mind. Sometimes this can get a little bit of a full-on task, so bear with me. Look, honestly, there's a very good quote, and I don't want to harp on, but there's a very good quote by Buddha, actually. There are only two mistakes one can make along the road to truth: not going all the way and not starting. So I'll leave you with that. Okay, the truth is there. The truth is right in front of our noses. We only have to start and go all the way. Best wishes.